So welcome, and I just realized I might be light on the lens, so I might make things up as I go. The title of this talk is MLOps, the strategic compass of AI-driven enterprises, and the goal of this talk is to show you a little bit why we think that any company that is using AI at some point needs to start doing MLOps, and basically how can we get started. A little bit about myself. My name is Diego. I'm the solution architect here at Tryolabs. I have a very technical background, degree in computer engineering, PhD in applied math, also with machine learning. And I've always been really interested in understanding how to make pipelines more efficient, especially when working with data. That's how, at some point, I found DBT. We had like a local meetup back in Uruguay about DBT. That's how we met Jenny, and that's the result of it. So, MLOps can be a little bit boring. There is so many terms from continuous monitoring and deployments and pipelines and observability and pretty much everything that you can think of. There's so many tools out there. And so it's hard to navigate this landscape. And that's why this talk is oriented at some basic guidelines that can get you started. So that's what we're going to be doing today. The goal is that by the end of this talk, if you done or you do MLOps today, you might get some ideas on things to try. But if you're getting started, you have a clear next step that you can go and move forward. So before I say anything else, let me introduce Tryolabs. Tryolabs is an AI consulting and services firm. We specialize in AI, and we are hands-on. That means that we work very closely with our clients and provide excellent services and help them accelerate the AI adoption. We started working in 2009 mostly for startups in the Bay Area, and slowly grew to larger companies, and we're currently working for some large 500 companies. Some of our clients do from real. We have worked with NVIDIA, Graph, CFL. Most of our customers are here in the US, but we have also worked with some in Europe. And other things that you might be interested in knowing, we have a couple of open source projects. One is called Northport, for computer vision and object tracking, and the other one is Temporian. And my last slide is about that, so I'm gonna give you that cliffhanger. We are a Google Cloud certified partner, and for a long time we were banks and companies execution arm in Latin America. So whenever they were facing a very challenging project, we would basically have them do that implementation. Having said that, let me get started. This is our agenda for today. I'm going to introduce you to the 4 stages of our MLOps journey. Then I'm going to describe each of these 4 stages in a little bit more detail, and then I'm going to go through some remarks. And because I like talks that are a bit weird and different, I have a couple of stories that might be slightly unusual, but I think that are good at conveying why MLOps is important. And so every now and then, I'm just going to stop whatever I'm saying and just throw a story. I'll do slides for those. All right. So the key stages of our MLOps journey. Therefore, the first one is getting your data in order. The second one is experiment and model tracking. Then we have standardizing your production process. And finally, we have model and data monitoring. And if you have read some of the white papers out there on MLOps journeys, ours is a little bit different because we have a very strong emphasis in data first and automation later. And even though this might not be the traditional way of doing things, we do believe that getting the foundations right is critical for success, and so that's why we definitely recommend starting this way. So, getting your data in order. Why would you want to get your data in order, or when do you think, how do you know that you might need to do something about it? Here are some of the key challenges that we see clients facing that prompt for some sort of corrective action. The first one is lack of centralization. If all your data lives in different places, at some point it becomes really hard to just get it all together and start working on whatever problem you're trying to solve. It might be that you have poor data quality. It might be that data where it lives is full of missing values. It has a lot of text fields that should be lists of enums in Python. It might be that there's lack of documentation, and whenever a new member joins your team, they struggle because they don't understand what they can do with the data, what's pronouns, basically, where should they use it, or there might be no reusability. And so this is a case where a lot of team members are basically repeating a lot of the work, especially around clean data. If the data has good quality and we need to clean it, and there's no standard way of cleaning the data, we might see that there's a lot of repeated code. So what strategies can you follow to improve on these things? The first one is centralization. Centralization is fairly standard. There's a lot of data lakes that you can use to get all your data in one place. Snowflake, etc., etc., etc. Then there's data quality improvements, and here just making sure that whenever you're storing your data, the data is clean and it's ready to use. That can make a huge difference when it comes to accelerating the pace of your development. Prioritize documentation. This is key not only in software development but also in machine learning. We all seen, sorry for that, code that we don't understand because there's no docs, there's basically no way of knowing what's going on. And with data, let me just start very quickly. That shouldn't be happening. So if you manage to get documentation for your data, and we're going to see that's something you can do. There are several good templates that have good practices on how to document data. Then you can make onboarding of new members or just the members that are new to a given particular data set a lot easier. And finally, promote reusability. If, as I was describing earlier, you need to clean your data. And that process has to be done often and often. It might be a good practice to keep, for example, and this is a very simple solution, a set of SQL queries that you use to clean your data, readily available for all your team members to use. And even then, if at some point you realize that you're using a new query that is not in the repository, you can have a session where pretty much you align on these are the set of queries that we are often using to clean up. Again, these are simple fixes, but this can massively reduce the amount of work that you need to do. And so, as I was saying, I'm going to have a couple of stories here, and then. And this one is about employees that couldn't take holidays. And I might be exaggerating this a little bit, just for the sake of storytelling. But this is based on a real story that happened right now. So, once upon a time, there was a team of engineers tasked with creating an ETL pipeline. The goal was to make data flow as efficient as possible, and they were very good at it. They basically managed to build this amazing infrastructure with only a team of 3. One day, someone was tasked with building a new machine learning model. They had to use a data source they had never seen, and they were searching for it. The problem was that when they actually found the data, they realized they had no idea how to use it. So they went and they asked the ETL team, because those were the guys, the uplifting for the data. Hey, how do I use this data? And of course, they got an answer. I was like, oh, this is great. I'm gonna just do that next time. And because of that, the ETL team very quickly became a bottleneck of that organization. Because whenever someone needed to know something about the data, those were the people they were asking the questions. And so if those people were not available, it was not knowing what the data was, how to use it, and basically that stopped progress altogether. So no holidays for them. Maybe not holidays, but they had to take the phone because it's not as relaxing. So how do you solve this issue? One way of doing it is like data gathering. You can decide to create a repository where you document all your data and you specify exactly what's the provenance of each attribute, how it's supposed to be used, and pretty much offloading that knowledge that was only within those two people into something. And there are several ways of doing this. This is a sample of something called the Data Nutrition Project. And what you can see here, the draft thing, my screenshot, is that it describes, for example, who owns this data, who maintains it, and several things that you might need to know about its provenance, how much you can trust several fields, what's its intended purpose. And the idea is that if you have this for all your data sets, you might not know exactly all the information you need, but you have a lot better understanding, especially if you're not just dealing with one or two data sets, but you deal with hundreds. So as your organization scale, doing these sort of things becomes a lot more relevant. Wow, that was. All right. So the next step, if you have your data in order, is experimental model training. And so you might wonder, how do I know if I need experimental model training? And the answer is as follows. You might find that you have hard time reproducing results. You run an experiment, 2 days later, you cannot remember exactly why you got the result, you run your code, not the same. That's a bad signal. You have collaboration barriers. If everyone's working on their own Jupyter notebook, at some point it becomes hard to share code, share models, and conciliate whether an experiment that someone ran, it actually improves the thing because they actually did a little bit change here and what was that result? So because of that, experimentation is inefficient because we might be running the same experiments over and over and we just don't know if there's no reliable way of comparing my experiment with their experiment. And overall, this impacts our ability to know how well a model is performing, right? Because if we cannot compare models because they are not apples to apples, because versions code might be different, then what are we doing? So solutions. There's two here that I think are really important. The first one is embrace experiment tracking. There are a lot of solutions here. Hi there. Basically, if you have a good experiment tracking tool, you can, every time you run an experiment, it gets uploaded with these parameters, maybe the source code, versioning, git commits, everything that you need to know exactly how to get the result. And if it's a good tool, you might get some nice add-ons. The other one is adopt a model registry. If you have a way to put every trained version of your model somewhere, and then you can reference that something, that registry, then it becomes a lot easier to basically rerun experiments because you can always download your trained model and say, okay, oh, that's great. That result was obtained with this model. Now I don't need to retrain my model. I can just download the parameters and run. I think that we're all familiar with that, especially around like mentioning links and so this is on the far-fetched side of stories, but stay with me. So we had a client that once upon a time was searching for an experiment tracking tool. Why? Because they realized it was really important. So they realized evaluating, they just needed a tool. And so they went on a hunt for one, they found one, but one day the latency went up. Basically, experiments were not tracking as well. It wasn't completely down, but things were not working properly. And they didn't know why. And what's interesting is that at this point, because experiment tracking is so useful, not being able to track experiments pretty much brought day-to-day work to a halt. Like a great occasion to just go and watch YouTube. What had happened after a little bit of digging, a volcano had erupted somewhere. You might wonder, like, well, why is this relevant? If you don't know, like top-level domains like .ai and .ml actually belong to countries. So .ai, I have it here, is Anguilla. .io is the British Indian Ocean Territory, and .mm is Mali. Which means that if you actually want to access those services, you actually need to run a DNS query that goes to maybe not Mali, but a server that's somewhere there. So that means that if for whatever reason you get a volcano somewhere near Mali, that might actually impact you in a way that you never expect. Because of that, the team could not work. As I said, the server was down. And once you start doing experiment tracking becomes amazing. And so you really depend on the services that you're buying. The solution in the end, as you can imagine, someone fixed those submarine cables. There was also a .com subdomain, so the MLOps team could quickly change that and they got their service back up. But that goes to say that when you're doing machine learning, we sometimes think that it's just running my Jupyter notebook and getting the result. But in practice, there are a lot of things that we need to keep top of mind. And I think this shows a little bit the speed of MLOps. MLOps is not just having a good data versioning or having an experiment tracking tool or being able to observe your models. It's basically making sure that models run reliably in production all the time, and weird things can happen. Having tell you the story, what is an experiment tracking tool? And so here is a snapshot of DVC Studio. This might be an old snapshot, so I'm sorry if this is like version 1 version 10 right now. But what can you do with an experiment tracking tool? So first of all, you can track experiments and you can get all the metrics that you want to track for each one of the experiments that you run. But you should get nice additional features such as like plotting on those experiments, so to be able to visualize them a little bit more. Compare results if there's particular experiments that you want to track, like metric to metric or in additional parameters. Running experiments, this is nice. If you actually get everything configured, you might actually be able to use your experiment tracking tool to run experiments instead of just going to your editor of choice and running things. And even generate trend charts. So again, experiment tracking tools are usually more than just experiment tracking. They are a way to achieve a lot of unification and coherence in your team, because now you're just not looking at your own VS Code or game or I don't want to say emails because that's that. But all your team has a unified view of what's going on with your models. All right, so we got our data in order. We have a standard, we have experiment tracking. And now the next thing is, okay, we need to get these models into production. And what can be hindering your process here? The first one is lack of reusable code. Especially if you find that every time you want to deploy a model in production, you need to write a fast API server to basically configure how you're going to get your requests. That's something you're going to improve on. You might have maintainability concerns, because if at some point you have a lot of models running on, who's going to look for those? And how do we make sure that we know that all of those are running? And finally, and I think the most critical for this one, is delay in deployment. We usually have separate teams, one that does all the experimentation, one that is in charge of making sure that these models run. And if there are not good processes in place, what happens is that, oh, I have my model, I got this amazing accuracy, let's put it in production. And there it might be like weeks or months before that model actually sees the light. And the organization loses a lot of value because of that. So we want to make sure that these things can happen with a click. Not always the case, but that's sort of what we want to do. And so how can we make sure that this happens as smooth as possible? I would say that it's all about processes and guidance. So on the one hand, you should have standard templates on how to serve models, either batch or online, and say, if you're deploying a model that's going to run batch, do this. If you're going to do a model that's going to run on online to this and have standard code that you can use for both cases, and you don't have to reinvent the wheel every time. The other thing is having standard production environments. And so the same way you use something like Poetry or Pip to track your dependencies, it's critical that if you're going to be running in production, that you have a standard production environment. And so for these things, Docker is king. And what we find is that if you have a team develop a standard Docker container where all models are going to be running in production, that's going to add a little bit of friction in the development process because the team might need to allow to that. But then putting that model in production is a risk because if it runs there, then it's as simple as setting it. And so if at some point you find that getting your models from experimentation to production is a bottleneck, you might want to think about doing these two things. And this is my last story, I promise. It's about the matter of that, of updates, and why we need to have standard production processes. So once upon a time, before Vertex AI, I'm sorry for Microsoft folks here in the audience, and Amazon, there was something called the AI platform prediction. And the way you would deploy a model with the AI platform prediction is that you have to build a library. And the same way you build a library in Python. Basically, you have a PyProject terminal and you specify some dependencies. And then once you build a library, you upload it. I don't know if you have built libraries in Python, but because you want more large amount of users to be able to use them and install them, you usually keep dependencies loose. You don't want to say, I'm going to pin this dependency to a given number because that really constrains the amount of users that are going to be able to enjoy. And so that was what we're doing. Until one day you will say like, hey, I'm going to update this dependency that you're using here. And of course, that broke apart. And because the kind of code that we were running was a set of modules that were used in other projects, basically, that cascade. And most of our production went down. And at this point, you're in a frenzy mode trying to understand like what's going on, like why is this not working? Until you realize that the production environment that Google was using that was not necessarily as visible to us had updated one dependency, and that dependency impacted. It takes a while, and you really don't want to get into this. So that day, the solution, of course, I mean, that day we did something else. That day we just clean all the dependencies and make sure that thing could run, got it working. We did leave another day. But eventually you want to use them. And you want to make sure that you know exactly where your models are running. So regardless of what's the hardware beneath it, you know and you can test exactly those models. So please use Docker in production. And finally, if you have done all this, if you got your data in order, if you had experiment tracking so you were able to iterate efficiently, you have a good process of putting models in production. At this stage, you probably have a lot of models in production, which is a good thing. But you might run into some issues. And especially if your users are the ones that are giving you feedback on, hey, this model is down, this model is not working. There's a bunch of biases with your models. Then you have a problem because you don't want your users to be the ones that tell you you have an issue with your model. You want to learn that early and fix it before they actually learn. So what can you do? The key here is monitoring. You want to monitor your data for data shifts, for example. COVID was a massive data shift that actually impacted a lot of models production. You want to have model monitoring. You want to be able to track all of your metrics, but also how efficient that model is, how much you're using. And also you want to be able to observe, like with a very fine-grained logs to really understand everything that's happening where your model is running. And so again, there's a lot of tools that can help you with this. I have one example here. It's called Tryolabs. And one of the things you can see here is for different profiles of days. I'm looking at different for different features. I'm looking at different distributions of data. And so what this gives me is an overview of what kind of data my model is seeing on different days. And this allows me to really understand if at some point, let's say profile 3, my model starts performing a little bit worse, maybe I can correlate that to some of these distributions. And really having those insights. So I'm limited over time, so wrapping up, you wrote volcanoes, especially underwater ones. But no, seriously. Implementing MLOps in any company that wants to do machine learning production is essential. And at some point or another, once we scale, you're going to face these issues. Throughout this talk, we outlined a path to get there. We start with data and we add automation first. And even though it's always fun to get all those things automated, we think that getting your data in order is critical. And there's something I haven't talked about here a lot, but it's really important. That's why it's in a different color. People don't like change. And most of what we propose here is changing the way people do machine learning, getting them away from the Jupyter notebooks, getting them to use Docker. I mean, it all adds friction. And so you are going to face resistance. And so you need to expect that and you need to plan for it. Assuming that that's not going to happen is naive and it's probably going to bring your efforts to failure. And finally, if in doubt, refer to experts. There's a room full of people that know how to do MLOps. So we are always here to help. Thank you. All right, so we have, I think, 3 minutes for questions. I have 2 resources here if you are interested in checking them out. One of them is a white paper we wrote on MLOps. Basically, it's this talk but longer and with more details and with all the names of the tools that you might be interested in trying. The other one is the shorter version of the white paper and from the Funka blog. And while I'll wait for questions and you take a picture of those QR codes, yeah, I'm gonna show you this story. So, last tidbit, I mentioned it at the beginning of the talk. We wrote a library for temporal feature processing. Now, basically, if you use pandas for data processing, for time series processing, it's slow, it's not great, and you might lose things like leakage. So, we wrote Temporian, collaboration with Google. We have a webinar in which we explain what we do and how it works, and you can ask questions. But yeah, right, questions.
Yeah. When you're working with customers on adopting MLOps,
Yes.
and like I said, if they're working primarily with Jupyter notebooks, what's the biggest friction point you find in transitioning them to that framework?
So the question is, when we work with customers that are doing Jupyter notebooks, what's the largest friction point? I would say that it's understanding that there's much to be gained by adding a little bit of friction or changing the way they work. I would say that if you don't have a software background, having a CI/CD automated process for testing doesn't come naturally as something that you're going to get value out of. And so that transition to the point where you actually live that reality and see like, oh, life is so much better now. It actually takes a while to finish. So convincing people that it's going to get better, it's going to get worse before it gets better, I think that's part of the struggle.
So I try to get you guys to use chatbot.
Yeah.